At the 2020 WWDC, Tim Cook announced Apple Silicon, which would go on to disrupt the entire CPU industry, and it fundamentally changed the way we think about computing performance. Today, Nvidia is copying Apple's strategy. Microsoft had to rethink Windows, and Intel lost one of its biggest customers. Billions in revenue disappeared with it. By the end of this video, you will understand how the M processors change the devices sitting on your desk right now, even if you are not using Apple products. This video is sponsored by Boot.Dev, more on them later. Before the M chips, Mac sales were stagnant, and after issues with firmware throttling or such fiascos as the Butterfly keyboard, users were unsatisfied with the direction in which the lineup was going. When designing the next generation of Macs, Apple's hardware team had to make radical changes. They decided to ditch Intel and abandon the 40-year industry foundation, completely swapping the instruction set architecture. Up until 2020, every Mac relied on Intel's x86 architecture, the undisputed standard for desktop computing since 1978. But Apple Silicon was about to seriously disrupt Intel's dominance. x86 belongs to the complex instruction set computer or CISC family. Its instructions are designed to do more work individually, making programs compact while maintaining compatibility with decades of existing software. But that compatibility comes at a cost. x86 instructions vary in length and complexity, which means the processor has to spend more work decoding them before they can actually be executed. That extra complexity translates into higher power consumption. Intel spent decades optimizing for maximum performance and backwards compatibility. Apple optimized for something else entirely: performance per watt. That single decision changed the design philosophy of not just Apple, but the entire industry. When making the M1 chips, Apple abandoned x86, or more specifically, Apple abandoned Intel as their partnership was in a really poor state. As journalists noted, Intel made the classic business mistake: overpromise and underdeliver. Their push for ever faster clock speeds looked wonderful on benchmarks, but in reality the CPUs generated so much heat that those speeds were never achievable in a real-life scenario. This issue was really apparent on the Touch Bar Intel MacBook Pros, which would get as hot as a stove, and users reported that it is impossible to do any work with the laptop on your lap, which completely defeats the purpose of a laptop. Instead of continuing down the same path, Apple bet on ARM, a reduced instruction set computer or RISC architecture. RISC instructions are much simpler and fixed in length. Individual instructions do less work, but they are easier to decode, easier to pipeline, and far more power efficient. Rather than making each instruction smarter, ARM relies on executing many simple instructions extremely quickly. Before Apple, ARM chips were an unpopular choice in the mainstream laptop and desktop market. They were only ever used on mobile devices, and it's not because people didn't try. Microsoft placed an ARM chip on the Surface RT. Qualcomm tried it with Snapdragon laptops. Samsung, HP, and Asus all tried it as well. They all promised incredible battery life, but they shared the same problem. Software compatibility was awful, performance was mediocre, and almost nobody bought them. Seeing this, you might think that Apple's decision to use an ARM chip for the new design was bold, and honestly, it was. But they took notes and decided to improve on what their competitors failed at. And this would soon disrupt the entire computer market, because you see, the M chips weren't Apple's first attempt at designing ARM chips. In fact, the foundations of Apple Silicon had already been laid more than 2 decades earlier. While Intel spent years trying to make desktop processors faster, Apple had a completely different problem. In the early 2000s, they weren't just a computer company anymore. They were also selling a huge array of mobile devices. In 2010, Apple showed their first in-house designed chip, the A4. It got placed in the iPhone 4 and the original iPad. But how do you build a processor powerful enough for a smartphone that barely has enough battery to last a day? In that case, you are forced to optimize for efficiency from day one. And as it turns out, the A4 is what eventually paved the way for the M1. Over the years, Apple got so good at making efficient chips for their mobile devices that eventually the iPhone started to outperform the state-of-the-art Intel chips that were present on Macs. Around the premiere of the iPhone 12, things got completely out of control. A YouTuber, Jonathan Morrison, posted a video rendering the same footage on a well-equipped Intel iMac with a 10-core i9 and 64GB of RAM and on an iPhone 12 mini. Even after giving the iMac a significant head start, the iPhone finished first. Now, to be fair, Apple's chips include dedicated media engines that massively accelerate video encoding, so this wasn't a pure CPU versus CPU comparison. But that almost makes the point even stronger. Apple wasn't just focused on making faster CPU cores, they were designing entire systems around real-life workloads. Apple faced a strange problem. Their phones had become so good that they were embarrassing their own laptops. And that's exactly why Apple Silicon was so disruptive. It proved that a carefully designed, efficient ARM-based system could outperform an x86 powerhouse. And soon, the rest of the industry would pick up on this idea as well. But remember why every other ARM laptop failed? It wasn't the hardware. It was that none of your software ran on it. And in 2020, every single Mac app in existence was built for Intel. Photoshop, Chrome, CAD. 20 years of software, all of it written for a completely different architecture. So Apple was about to ship a laptop that, on paper, couldn't run anything useful. But they had one trick left. And it's the reason the M1 didn't end up like the Surface RT. But before we get to that, I need to keep those purple lights on, so let me tell you about the sponsor of today's video, Boot.Dev. Boot.Dev is a platform built specifically to teach you how to code in a hands-on, game-like way. You gain XP, complete quests, and earn achievements while actually learning to program along the way. And these aren't just some random tasks. You build real, tangible projects from start to finish. I personally started the memory management in C course, and it's been genuinely fun. It introduces the core concepts of the C language, and by the end, you build your own garbage collector. Best of all the content on Boot.Dev is free to read and watch, and the paid membership unlocks interactive features. They also offer a 30-day no-questions-asked refund policy and a free demo of the interactive experience on every course, so you can try it, risk-free, and if you don't like it, you get your money back. Go to Boot.Dev and use my code CODEOLENSYS to get 25% off your first year on the annual plan, or scan the QR code on the screen right now. Thanks to Boot.Dev for sponsoring this video. Now let's get back to the topic. The M1, the first processor in the Apple Silicon family, was presented by Tim Cook at WWDC. It was an ARM-based system on a chip, meaning all key components such as the CPU, GPU, RAM, I/O, the neural engine, and codecs were all placed on a single microchip. On a typical PC, all of these components are a separate part that are then placed on the motherboard. Putting everything onto one chip brought enormous advantages such as extremely fast communication between the modules, as well as unified memory. On the M1, all the components access a single unified RAM. The CPU and the GPU are no longer passing huge amounts of data back and forth between separate pools of memory. They are simply looking at the same thing. Coming back to those early Microsoft and Qualcomm ARM devices that suffered from software compatibility issues, Apple found a way to solve this as well. They introduced Rosetta, a dynamic binary translator that made it possible to run x86 programs on the M1 before ARM-compatible versions would be released. Another huge advantage of Apple Silicon was the vertical integration. Apple now had their own hardware, operating system, and developer tools. They could directly optimize macOS for the new chips without making compromises on compatibility. No other company had that. None of these decisions alone made the M1 revolutionary, but when you put them together, you get a chip that has been dubbed the world's best CPU at performance per watt. Competitors had to adapt. Even Intel is now shifting its focus towards power efficiency as they attempt to alleviate the costs of running data centers. The company went through quite a rough period ever since their breakup with Apple, but they seem to be back on their feet. Though only time will tell if their x86 architecture will withstand the rise of ARM, because there is a clear growing trend in the popularity of ARM in the notebook market share. Analysts are speculating that in 2029, 40% of all laptops sold will run ARM-based CPUs. AMD, Intel's biggest competitor on the x86 market, is also rumored to be working on an ARM-based system on a chip. Again, something that wasn't really a mainstream thing before the M1. But what's even more strange is that this year, Nvidia entered the CPU market. Jensen Huang, the CEO of Nvidia, put on his leather jacket and unveiled RTX Spark, an ARM-based system-on-a-chip platform designed for Windows laptops and compact PCs. Think about how unusual that is. The biggest company in the world that built its reputation on graphics cards is now betting on the same philosophy Apple proved with the M1, that efficient, ARM-based systems are the future of personal computing. This has pushed Microsoft to adapt as well. Ironically, the company that failed with Windows RTE more than a decade earlier is now investing heavily into Windows on ARM. In February, they released Windows 11 version 26H1 specifically for the ARM architecture that brought support and optimization to a wider range of ARM processors. Even Apple doubled down. The new MacBook Neo doesn't even use an M-series processor. It simply ships with the same A18 Pro chip found in the iPhone. 5 years earlier, the idea of selling a laptop powered by a phone processor would have sounded absurd. Today, it's beating sales records. Looking back, Apple didn't just build a faster processor, it completely changed the definition of a good processor. Thank you for watching, and once again, thanks to Boot.Dev for sponsoring the video.